Hello everyone, welcome to today's video where I take you through the process I have done in my object detection using deep learning project. So today what we are going to do is that we are going to detect weapons in an image or a video using the famous YOLO algorithm. I'll tell you what a YOLO algorithm is in just a moment, but before that, let me go through some of the common steps which we use in this process. The first one is the data preparation. So there are two ways which we can use to prepare our data. One is the easiest way, which is going through the open source network and collecting our the pre-trained weights and the labeled data, download those trained projects and use it in our own program. Or else there is another tedious process which is labeling our custom data. Yes, it is a tedious process because we have to download the positive and negative images and label them ourselves. But labeling these data sets is a very mandatory process. So let me show you a small example of how we can label our own image. So there is a open source Python file known as label image which we can use to label our custom images. So let me take you through those label image. So this is the label image graphical user interface. So this is an open source file. So we are able to label our data for two kinds of algorithms. One is the YOLO algorithm, the other one is a Pascal Obvious algorithm. In this case, we are using YOLO algorithm, hence we're going to select YOLO algorithm. I have a sample directory which we can use to show you an example of how to label an image. So, so yes, now we have a directory with four images. So this is one of the image. So what we do is that we go and create a rectangular bounding box in this image and we are going to give it a name. In this case, it is the name of our label, which is weapon. Then we are going to save this image. We go to the next image and repeat this process again. Create a bounding box, give it the label name, and save it. So we are going to do this for every image in our data set to create the custom labels. Now let me show you what happens after this process. So if I go to my sample data, you come up with this. It is a text file containing the data annotation of the labeled image. So these data annotations is what we use to train our algorithm for the image detection of weapons. Now, the next step in our process is selection of the algorithm, and in this case, we are going to use the YOLO algorithm. So, let me tell you a small intro into the YOLO algorithm, what it does. So, in the YOLO algorithm, we have this image. Now, what happens is that there's going to be a grid which is created onto this image. Let's say it is a 3 by 3 grid for now. And what happens is that the YOLO algorithm, when the training is done, it goes through each of these grids and looks for the presence of the object. So it goes to the first grid, to the second grid, third, the fourth, respectively. Stop. So after going through all these grids, it comes up with a boundary box on the image which is required. So this is what happens in YOLO algorithm. It goes through each grid and finally creates a bounding box on the respective object which we are going to detect. But also there's a possibility in this YOLO algorithm where there can be multiple bounding boxes detected in such way. Now this is where a technique known as max suppression comes in place. So in max suppression what happens is that the bounding boxes which have the least confidences are all discarded and only with the highest confidence level is retained. So in this case, the highest confidence level will be for this yellow bounding box. So the final output of the algorithm will provide us with an image having this exact bounding box out of the image. Next comes the training and evaluation part. So I'm going to use the darknet to train my YOLO algorithm with the custom labeled images, and we come up with these two files. One is the configuration files, another one is the trained weight files. So now what we are going to use is we're going to use this configuration file and our training file during our deployment in our Python file to detect the objects in the provided video or an image footage. Let us take a look at the demo of our model. Now I have this Python file over here which uses OpenCV module to detect the objects. So we have a DNN available in the CV2 where we are going to apply our weights and the configuration file. So let us see how it works. So let me go to my directory and open command prompt. Now let us run our program. I do have a video of a man holding a gun. So this is the image, sorry, the video. So let's see how well the program detects in this video. So there it is, the weapon is getting detected in the video. Well, the output of the program shows each frame with the weapon detected. Now let us look at an image file, a JPG file, to see how it detects in a image file. So I have an image of a Glock over here. So there it is, the weapon is getting detected. Now let us check for another image also. I do have an image of a handgun, a person holding a handgun. Yes, so the weapon is getting detected. It works fine in images also. Now let me show you a video which doesn't have a weapon so that we can look into the accuracy of it. So I have a CCTV footage over here. So yes, there is no misplaced bounding boxes in it. So the model works fine. So let me show you one more video of a man holding a pistol. So there it is. So the weapon is getting detected correctly in this video file and also in the images. So yes, our model works fine. So that's it. There you have it, the YOLO detection of a weapon in an image or a video. Thanks for watching.